I'll give you an example. So, there is a question which says, out of 4 teachers and 7 students, 6 persons are to be chosen. Okay. As I said you that there are a lot of people and then you have to make a team. So, 6 persons are to be chosen, but there are conditions. The first condition, there is only one teacher. So, making sure that in your 6 person there is only one teacher. So, what are the different ways by which you can select? How many ways in which you can select the team? Second, there is at least one teacher. Now, this is very interesting. When it is said there is at least one teacher, then there can be one teacher, there can be 2 teachers, there can be 3 teachers, there can be 4 teachers, but there cannot be 5 teachers, as because maximum number of teachers available is 4 only. Okay. So, if we have 4 teachers, then only 2 students will be there, because total has to be 6 percent. Similarly, if we have 3 teachers, then 3 students will be there. If we have 2 teachers, 4 students will be there. If we have 1 teacher, then 5 students will be there. So, that is the way how we will have to do it, considering all these cases. That is second. Okay. I will show you how to solve the sum. Then prove that. Prove that. Why did I take this relation? It is a very, very important relations. NCR and NCN minus R are exactly the same. So, I will show you how to prove that, and then there is a sum which shows the application of this proof. We are given find the value of R if 18CR is equal to 18CR plus 2. So, we are going to apply this very formula or this very rule that we have proved in this sum and find out what is the value of R. So, let us move on to the solution page. I will show you how to solve. So, here is the first question. Out of 4 teachers and 7 students, 6 persons are to be chosen. In how many ways these may be chosen if number A, there is only one teacher, and number B, there is at least one teacher. So, let us do number A. So, if there is only one teacher, so we will write number of ways in which one teacher can be selected from how many teachers? 4 teachers is equal to 4C1 ways. Okay. 4C1 is equal to factorial 4 by factorial 1 into factorial 4 minus 1 ways, which is factorial 4 by factorial 1 into factorial 3. So, this can be written factorial 4 is 4 into 3 into 2 into 1, but 3 into 2 into 1 is nothing but factorial 3 divided by 1 into factorial 3. These two gets cancelled. Factorial 1 will be 1 only. We will not be considering the, we will not be multiplying it with a 0, because as you know, factorials always ends with 1. So, after 1 we are not going to write 1 into 1 minus 1 or 0, it ends in 1. So, factorial 1 is 1. So, ultimately this is 4 ways. So, number of ways in which one teacher can be selected from 4 teachers is 4 ways. Okay. And number of ways in which 5 students, okay, can be selected from how many students? 7 students. Number of ways in which 5 students can be selected from 7 students is 7C5, okay, which is factorial 7 by factorial 5 into factorial 7 minus 5. This can be written as factorial 7 by factorial 5 into factorial 2. Applying the same technique, here also we can write 7 into 6 into, now the next will be 5 into 4 into 3 into 2 into 1, which is nothing but factorial 5 divided by factorial 5 into 2 into 1. Factorial 5 gets cancelled, 2 and 6 gets cancelled. So, we are left with 7 3s are 21. Okay. So, number of ways in which one teacher can be selected from 4 teachers is 4 ways. Number of ways in which 5 students can be selected from 7 students is 21 ways. Hence, the required number of ways, okay, in which 6 persons can be selected taking only one teacher will be equal to. So, we have to find out the product of these two. We have to find out 4 into 21, that is equal to 84. So, 84 ways. It is 4C1 into 7C5 and we will be getting 4 into 21, and that way 84 ways is the number of ways in which we can select 6 persons with only one teacher. That is part A. Next, I am going to show you part B, where it says that at least one teacher should be selected. Okay, so let us come to the part B. Now, it says out of 4 teachers and 7 students, 6 persons will have to be selected, but given that there have to be at least one teacher. Okay, so for solution B, when we say at least one teacher, there can be various ways how we can select 6 persons. There can be 1 teacher and 5 students, or 2 teacher and 4 students, or 3 teacher and 3 students, or 4 teacher and 2 students. So, these are the possible combinations. Okay. So, number of ways in which 6 persons can be selected with at least one teacher is equal. So, first let me give you the combination. Say for example, we take one teacher and 5 students, okay, plus 2 teacher and 4 students, plus we can have 3 teacher and 3 students, plus 4 teacher and 2 students, and that is it, because we do not have more than 4 teachers to select. So, maximum can be 4 teachers. Now, selection of 1 teacher will be 4C1 into selection of 5 students will be 7C5, okay, plus again selection of 2 teachers will be 4C2 into 7C4, then 4C3 into 7C3 plus 4C4 into 7C2. This is how we will be able to find out. Now, 4C1 is factorial 4 by factorial 1 into factorial 3. 7C5 is factorial 7 by factorial 5 into factorial 2. I have done the subtraction at this very step only. 7 minus 5 will give me 2. Then a plus sign. Again here I will get factorial 4 by factorial 2 into factorial 2 into factorial 7 by factorial 4 into factorial 3, plus sign again. Next is factorial 4 by factorial 3 into factorial 1 into factorial 7 by factorial 3 into factorial 4, plus sign, and then we will have factorial 4 by factorial 4 into factorial 0. Now, factorial 0's value is 1. Please remember, it can be proved and it is there in your book probably. There is a theorem through which we can prove that the value of factorial 0 is always 1. Okay. and into factorial 7 by factorial 2 into factorial 5. Okay. So, this can be written as 4 into factorial 3, 1 into factorial 3, these two can be cancelled. This is 7 into 6 into factorial 5, factorial 5 into 2 into 1. Again, this is 4 into 3 into factorial 2, factorial 2 into 2 into 1, and here we will get 7 into 5, sorry, 6 into 5 into factorial 4 by factorial 4 into 3 into 2 into 1. Okay. Plus sign again, 4 into factorial 3 by factorial 3 into 1, 7 into 6 into 5 into factorial 4 by 3 into 2 into 1 into factorial 4, then a plus sign. So, we will get factorial 4 by factorial 4 into 1, 7, 6, 5 factorial, 2 into 1, 5 factorial. Okay. Now, 5 factorial we can cancel, 2 3s are 6, 2 factorials we can cancel, 2 2s are 4, 4 factorial can be cancelled, 3 2s are 6 can be cancelled, 3 factorial can be cancelled, 3 2s are 6 is cancelled, 4 factorial is cancelled, these 4 factorials are cancelled, 5 factorials are cancelled, 2 3s are 6. So, let us find out what is remaining. Here only 4 into, here it is 7 3s are 21 plus sign. In this case, we will get 2 3s are 6 into we have 7 5s are is 35 plus, then we have 4 into 7 5s are is 35. Okay. And then plus we have 1 into, so it's 7 3s are 21. So, ultimately we have 84 plus, this is okay, is this correct one? 6 and it is the 6 35. Yep. So, this is 0, 210 plus this is 0, 140 plus is 21. So, we have 210 plus 140 plus 84 and plus 21, that is 5, 15, 455. So, it will be 455 ways. That is a way of doing it. If you are given the word at least one teacher means there can be 1 teacher, 2 teacher, 3 teacher, 4 teacher, it can be more than 1. So, that way we have to find out various groups, we have to apply combinations rules. In between groups there should always be plus sign, please remember, and within group there is always into sign. So, that is the way how we can calculate, we can find out, and we can find that there are 455 ways in which these combinations can be made. Okay? Yeah. So, I am going to show you an important relation in combination. The first one, it says it proved that NCR is equal to NCN minus R. So, the proof goes in this way. NCR can be written as factorial n by factorial r into factorial n minus r. So, this can also be written as factorial n by factorial n minus r into factorial r, correct? Now, there is a slight modification that we have to do. If we write it as factorial n divided by factorial n minus r, and then in place of this, if I write n minus r, see, n minus r. If I remove this bracket, I will get n minus n and minus into minus plus r. So, n minus n will get cancelled, I will only be getting r. So, in other words, R can be written as n minus r. In other words, n minus n plus r. These two gets cancelled. So, you are only left with r. So, in place of r, we have written n minus r, and the factorial sign will remain here. Now, if you compare this with this, when it is factorial n by factorial r into factorial n minus r, then we write NCR. Now, it is factorial n by factorial n minus r, and here it is n minus r. This, if you write it in the symbol, then it can be n c n minus r. Okay. So, therefore, NCR is equal to NC n minus r, hence proved. That is a relation, and it is a very important relation. NCR is equal to NC n minus r. Now, using this relation, I will show you how to find out the value of r in the second question. Second question says, if you have 18 CR is equal to 18 CR plus 2, question is find the value of r. Now, obviously, 18 are equal, but r cannot be equal to r plus 2. For no value of r, these two will be equal. Okay. So, what will we do is, we apply this very formula, this very relation to any one side, either this side or this side, and the other side will remain the same. So, suppose we say this implies 18 CR is equal to 18 C 18 minus R plus 2. 18 CR plus 2, which is NCR, can be written as 18 C 18 minus R plus 2, which is NC n minus R. Okay. 18 C R plus 2 can be written as 18 C R 18 minus R plus 2. Now, from these two, n's are same, even the r's will be same. So, we can compare. So, we can write therefore, r is equal to 18 minus r plus 2. In other words, we will get r is equal to 18 minus r minus 2. You shift this r to the left hand side. So, we will get 2r, 18 minus 2 is 16. This implies r is equal to 16 by 2, which is equal to 8. That is the value of r. Now, or suppose instead of applying the formula on the right hand side, what will happen if we apply the formula on the left hand side? Let us see. So, suppose from here I write 18 CR is given 18 CR plus 2. Now, I apply the formula on the left hand side. So, I will write 18 C 18 minus R is equal to 18 C R plus 2. So, therefore, here 18 minus R will be equal to R plus 2. So, I shift this minus R to the right hand side and I bring this plus 2 to the left. So, 18 minus 2 is equal to R plus R, okay, which will give me 16 is equal to 2R. Therefore, R is equal to 16 by 2, which is equal to. So, whether you apply the formula on the left or you apply the formula on the right, you will always get the right same answer, which is R is equal to 8. So, this is the application of this relation through the help of a sum that I showed you. There are many such interesting sums as far as permutations and combinations are concerned, and it even helps you in your business strategies as and when you feel like starting off something of your own, or even you are associated with an industry. So, it's a very important concepts which you can practice more, because the more you practice, you will be able to understand and you will be able to get a proper clarification of when do we apply permutation and when do we apply combinations. That is all about set theory. So, here we come to the conclusion of the unit 2 of your business mathematics syllabus of set theory. Thank you very much.